Hey physics friends, and welcome to the projectile motion concept video. I'm going to go through all these questions. My questions that I'm going to go through today are going to be in order, but I've programmed this thing to kind of be jumbled for you. So you're going to see some sort of linearity to the questions that I go through, but then when you go through it, they're not going to be in the same order. But if you remember it or you get the idea from what I'm doing here, you can take it over to your quiz. So the first question says, which ball hits the ground first? One that's launched at an upward angle or horizontal? It's going to be the one that's launched downwards. Letter C. Because you're throwing it, you're giving it an initial velocity down, so it's definitely going to hit the ground before the rest of them. The next question, a bullet can shot from a high velocity goes 100 feet. No, not at all. That's totally false. The moment that the barrel stops supporting that bullet, it starts dropping. So no, it's immediately dropping. In fact, that's how guns work, that the scope is pointed down so that you aim up so that the bullet actually crosses the line of the scope twice. So this one here, no, false. You wish to drop a cup in a thing. You have to drop it beforehand because it always has a constant forward velocity, so you're going to drop it before. If you drop it when you're right above it, it's going to keep going forward and miss. I saw this a lot when I ran in a half marathon. There's just tons of cups beyond because people will get above it, they drop, and hard to make it in. All right, now we get into some of the projectile problems. So here's what I'm going to do. Every single projectile, the acceleration, it's always accelerating down. It doesn't, no matter where it is, at any point in its trajectory, its acceleration is always down at 9.8 meters per second squared. So that's going to be negative because in my problems, I'm going to assume that up is positive for everything. So the acceleration is always down at negative 9.8 meters per second squared. Now the velocity, you use sine and cosine. So at the beginning, I'm firing it forward at 50, and I'm firing it up at like 86 points, I think 6. Up at the star, it's still moving forward at 50. Here's the idea with projectiles. No matter where you are inside of the trajectory, you're always moving forward at 50. You're moving forward at a constant speed. So, which is, in my video, I showed those kids with that bowling ball, and then they drove underneath it like the wind blew it over top because they both move forward at a constant speed. So I'm going to bring these ideas into a lot of these questions. So this one right here in mine, it's number 4 on mine. What's the horizontal component of the projectile's velocity at launch? 50. What's the vertical component of the velocity at the vertical component, the up and down component, is 0. There's none. The vertical component at the red star is 0. The horizontal component at the red star is 50. It moves forward at a constant speed. What's the vertical component of the projectile's acceleration? The acceleration is negative 9.8. The vertical acceleration is down at 9.8, negative 9.8. What's the horizontal component of the velocity? 50. It's moving forward at 50 at that spot. What's the vertical component of the velocity? So when it hits the ground, it's moving 50, and then it's going to be going down at the same speed that I launched it at, assuming that I launched from the same level ground. So this thing hits the ground vertically at negative 86.6. It's moving down at 86.6. What's the speed at the end? The velocity of it, you have to take into account the fact that it's moving forward at 50, and it's moving down at 86.6. So the velocity of it, a squared plus b squared, you better believe it's actually 100. It hits the ground with the same speed as it was launched with. Now, I'm assuming no air resistance in all of these problems. And I think I get some questions about air resistance. How would you expect a projectile to go higher? No. Actual air resistance, this thing actually goes nowhere near what it's supposed to do. So it's definitely going to go not as high. Would you expect it to go farther? No, it's not going to go farther at all. Air resistance is going to slow it down and not allow it to go as far as it possibly could. Now we get into going over things like off a cliff. So same idea. Anywhere on the trajectory, I'm moving forward at 50. Again, I've already done this using sine and cosine. So at the top, it's still going forward at 50. Right here at some random place, it's still going forward at 50. When it's here, it's moving forward at 50. And at the ground, it's still moving forward at 50. Main idea is that projectiles always move forward at a constant speed. Vertically, they're always changing speed. At the beginning, it's 86.6. Right here, the vertical component is 0. Right here, the vertical component is something. Right here, the vertical component is negative 86.6. And down here, it's something more. I don't know what it is. I'd have to do little calculations. And I would have to know this distance in order to get the actual vertical velocity. So let's go. What's the horizontal component of the projectile's velocity at that spot? It's 50. You're moving forward horizontally at 50. What's the horizontal component of the velocity there? Oh, also 50. You're moving forward always at a constant speed. What's the vertical component of the projectile? Oh, the vertical component, again, it's going to be bigger than 86.6. I'm going to go with 100. I could be wrong about that, but I'm going to go with negative 100 right now. Again, you can't tell is the correct answer, so negative 100. I'll program that one as the correct answer if you get, or other. I'll accept them both. What's the vertical component of the projectile's velocity? The vertical component right there, since it's in line with where it started, that vertical component is negative. It's going down at the same speed it was launched at, 86.6. So negative 86.6. What's the vertical component of the acceleration? It's always accelerating downwards at negative 9.8. So anytime you see the word acceleration anywhere, vertically, the vertical acceleration is 0. Horizontally, the acceleration is 0. It's not accelerating horizontally, but it's always accelerating down vertically. So the answer to this one is negative 9.8 meters per second squared. What's the vertical component at the negative 9.8? So again, keyword acceleration always accelerates down at negative 9.8. The next problem, now we go launching off a cliff, and I'm launching at a downward angle. So again, I'm launching it forward at 50 again, and I'm launching it down at 86.6. So again, anywhere on the spot, I'm going to be moving forward at 50. Even at the very bottom, I'm moving forward at 50. But I'm getting faster. So if this is 86, this is going to be like, I don't know, 100, anything bigger than 86, and this is going to be even more. Still like 120. You have to know this distance to be able to like calculate any of that stuff. So hopefully they don't ask it to us. And remember, acceleration is always this way at 9.80. Let's go. Vertical component of the projectile's velocity at launch. So negative 86.6. I'm launching it down, and down is negative. Negative 86.6. The horizontal component is 50. So positive 50 because to the right is positive. The vertical displacement at launch until, so vertical displacement is how far from launch, which is right here, to the end. That vertical displacement is 0. It's not moving up. It's landed at the same place that it took off. So the correct answer is 0. What's the vertical displacement from launch until that star? That's going to be 390. So it starts here vertically and it ends there vertically, so that's going to be 390. 23. What's the horizontal displacement from launch until the star? The horizontal displacement. So horizontally, it's going to be half of that 890, which is 445? Yeah, so 445 meters. And that's the positive direction. So you're going to say positive 445. Number 24. What's the horizontal displacement from launch until there? So from launch until here, horizontal displacement is 940 meters right there. And our last question. What's the vertical displacement from launch until there? Vertically, I start here and I end here. So I'm going this way 100 meters, and that's a negative direction. Negative 100 meters. So there you have it. the big idea and the reason that I'm sending you through this rigmarole is that when we start breaking up our problems, you have to know if I launch from here and I want to go there, and if I ask you how much time is it in the air for, you can use that the fact that the displacement is negative 100, the acceleration is negative 9.80, the initial velocity, I'm firing it up at 86.6, so it's a positive 86.6. So then you can find the time, right? Knowing which numbers to put into these problems, super important in this chapter. So good luck. Give that one another stab, and I'll probably just delete that question that was kind of out there. Good luck.